welcome to No Physics with me. Hope all are doing good. Yes, so we have already started with Physics CBSE class 10, chapter 10, Light, Reflection and Refraction, and this is our 8th part. So we have already done with 7 sessions. So first 5 sessions covers the reflection part of the chapter, and from 6th session we are covering refraction part. So 6th session we saw what is refraction, and we compared it with the day-to-day life examples. Okay, so where refraction occurs. Then we saw the laws of refraction in the previous video, that is 7th part, laws of refraction, and before which we saw how refraction takes place inside a glass slab, okay, rectangular glass slab. So in this session we are going to learn about refractive index. Okay, so Snell's law, the one which we saw in the previous chapter, laws of refraction, second law we saw, right? Sine of angle of incidence to the sine of angle of refraction is equal to a constant, and I said that constant is nothing but a refractive index. So from that we will start the topic. So we will entirely cover refractive index in this session. Okay, yes. So if you are a viewer who is getting directly into this topic, kindly watch 6th and 7th session and come to this session, because there we learn the basics of refraction. Okay, based on that only we are going to explain refractive index. Clear? Yes. So how do you explain a refraction? You have two different medium. Okay, let this be the separating line for the two different mediums, and let this medium be air and this be water. Okay. So this is our first medium and this is our second medium. Okay. So now let us draw a normal. Okay. Normal is nothing but a line drawn perpendicular to the surface. Okay. Now when I have a incident ray which is obliquely moving from one medium to another medium, what happens to my refracted ray? Here refraction takes place, right? As we have already seen, when our light is moving from one medium to another medium, what will happen? Refraction takes place. So as a result of refraction, what will happen? There is bending of light, which means light does not travel in straight line. Instead, it bends either away from the normal or towards the normal, depending on the medium we have chosen. Here it is moving from rarer to denser medium, so it will move towards the normal. So this is our incident ray and this is our refracted ray. I hope you are all clear till this. Yes, this we have already covered. So why this bending takes place, that also I have already explained. This bending wholly depends upon the speed of light in the medium. Okay, so as we know, the speed of light in vacuum is 3 into 10 power 8 meter per second. Whereas the speed of light in air is actually 0.003 lesser than this. Lesser than 3 into 10 power 8 meter per second. But since the value is very small, okay, so it can be neglected. So we will consider the speed of light in air also to be 3 into 10 power 8 meter per second. Clear? Yes. The speed of light in water is comparatively less than this. 2.5 into 10 power 8 meter per second. Okay. Likewise, for different mediums, there is different speed of light. Why does this happen? Because when it is moving through different mediums, it is rarer medium. Rarer medium means which is less dense when compared to the denser medium. So in rarer medium, the light can pass through very easily, okay, without any objection. Whereas in the denser medium, it travels a bit slowly when compared to the rarer medium. That is why there is change in speed of light. This results in bending of light, due to which refraction takes place. Okay, look how they are interconnected. Okay, yes. Now we will learn what is refractive index. Refractive index is nothing but to how much extent the bending takes place. Okay, why this bending is taking place? Because the speed of the light is reduced in the second medium when compared to the first medium, right? Yes, that is why the bending takes place. So how much extent it is bending is nothing but refractive index. So from this you can learn that if the bending is more, you will have refractive index as more value. If the bending is less, the refractive index value will be less. Okay, so you can conclude that refractive index is denoted by the letter N for now, and in higher classes you may learn it as mu. Okay, some other symbol. For now, in 10th standard syllabus it is reported as N. Okay, so refractive index is inversely proportional to velocity or the speed of light. Can I say like this? Because when does the bending takes place? When the speed of the light is reduced, right? So if the velocity of light is reduced, my refractive index will be more. If the velocity of the light is more in a particular medium, my refractive index, that is bending, will be less. So obviously my refractive index will also be less. Clear till this? So this is what is refractive index. So refractive index is nothing but to how much extent bending takes place. Bending of light takes place based on medium. Clear? So this is what refractive index is. Okay? In refractive index we have two types. One is relative refractive index and another is absolute refractive index. We will see in detail what it is. Okay? So now we will discuss about relative refractive index first, and then we will move on to absolute refractive index. So the same example let us consider. Now we are going to consider the first medium as a rarer medium, which is going to be air, and the second medium as water medium, which is a denser medium. Okay? Yes. Now I write like this. What does this mean? It is the refractive index. What is meant by refractive index? It is nothing but bending of light, right? Yes. How much extent? So, where is the bending of light taking place actually? In the first medium or second medium? In the second medium, right? So, with respect to the first medium, the second medium ray of light is bending, right? So, how can I call this as is the refractive index of the second medium with respect to the first medium. Okay, so if I write this, I can write as refractive index of medium 2 divided by refractive index of medium 1. Right? Yes. Now I can write the same N21 refractive index of second medium with respect to first medium in another way by using the velocity of light or the speed of light. Okay, we have already seen the speed of light is inversely proportional to the refractive index. Yes, so since the speed of light is faster, that is it moves in vacuum, means your refractive index won't be anything. If it moves in a denser medium, okay, in that case you will have a refractive index. You understand? So it is inversely proportional. So if I write refractive index in terms of velocity, how can I write? It is nothing but the speed of light in medium 1 divided by speed of light in medium 2. You may have a doubt, why here medium 2 and here medium 1, why here it is medium 1 to medium 2? Because already we know refractive index is inversely proportional to velocity. So actually it is inversely written. You understand? It is, if it is refractive index of medium 2 divided by refractive index of medium 1, I have to write it as 1 divided by in such way. You understand? 1 divided by speed of light in medium 1 divided by speed of light in medium 2. So when you take 2 up, what will happen? Speed of light in medium 1 divided by speed of light in medium 2. I think you are clear till this. Yes? So your refractive index is inversely proportional to the speed of light. You understand? Yes. This is nothing but called as a relative refractive index because you are comparing with one medium or relating it with first medium, right? So that is why you call it as relative refractive index. Clear? Yes. Now we will see absolute refractive index. So absolute refractive index is quite easy, okay. So first, speed of light either in vacuum or air if you consider it to be the first medium, and second medium is any other medium, then you call it as absolute refractive index. Okay, always remember, if suppose here it is water and glass, there are different mediums, right? That time you will use relative refractive index. When your first medium is either air or vacuum, you say it as absolute refractive index. Understand? So it is denoted by the letter N2. So this absolute refractive index can also be said as normal refractive index. Okay, simply if you call it as refractive index, you can write about absolute refractive index. That means the first medium is taken either to be air or vacuum. That is, the speed of light in vacuum is 3 into 10 power 8 meter per second. For air also we are going to consider the same value because the change is negligible. Clear? So that is what is called as absolute refractive index. So N2 is nothing but absolute refractive index, and you have a formula for this. I'll tell you how it comes. So for absolute refractive index, it is given by the formula C by V. Okay, so what is this C and what is this V? C is nothing but the speed of light in vacuum or air. It is always compared to vacuum. Okay, speed of light in vacuum, which is equal to 3 into 10 power 8 meter per second. And V is nothing but the speed of light in the second medium. It may be glass or water or some other medium. You understand? So that value you will consider as V. And the N is nothing but the refractive index. So you may have numericals based on this. They will give the refractive index value, and the speed of light in vacuum and air is 3 into 10 power 8. They will ask the velocity of the light in the second medium. Okay, or they will give the velocity of the light in the second medium and they will ask for the value of refractive index. So anyhow they ask, you will use the formula of refractive index as N is equal to C by V, where N is the refractive index and C is the velocity of the light in vacuum and V is the velocity of light in the second medium. You understand? So this is all about refractive index. So the refractive index for different pair of medium, you have different values. Okay, so you have that in your as a tabular column in your textbook. You need not memorize it, just understand. So for a given pair of medium, how the refractive index value will be. That is, keeping the first medium to be air or vacuum, how is the refractive index of the second medium with relation to the first medium. Clear? Yes. So I hope you are all clear with what a refractive index and how it is related to the speed of light, okay, in different mediums, and how you have to write a relative refractive index and absolute refractive index along with the formula. And also, if you have numericals based on refractive index, how to calculate it. Yes, just substituting the values for the above formula. Okay. So I hope you are all clear with these concepts. Yes. So now I think you won't find any difficulty in understanding what is refractive index. You will have a better understanding, I guess. So do read your textbook. So we will have a better understanding of all the concept we have seen here. And also, if you like the video, do share it with your friends and do subscribe my channel. So thank you for watching this video. Thank you for all the support given. Keep supporting. So thank you.